Hello everyone, welcome back to tutorial 7 in our series. So today we're going to talk about databases, which is a huge topic, but in every useful web application, there needs to be some data that's kept about it. So for example, users, products, reviews, friends, posts, purchase history. So all of these are examples of persistent data, which means that this data has to persist even though we shut down our web application. So right now, our server holds a bunch of user objects, but every time we restart, we're going to have to recreate these user objects. So wouldn't it be great if there was another system that kept all of this data and it keeps it even though we restart our web application? So that's where databases come in. So databases have two categories, structured and unstructured. And in a typical web application for beginners, we're probably going to stick with a structured format, which uses a language called SQL. So for example, we have users and we know that users need a name, a password, a size. So this is structured. So in this video, what we're going to do is create a database on render.com and we're going to connect our application to it. So let's dive in. What we have right now in our web application is we have an endpoint called user/view. And when we go there, we again create our users dynamically. And these are just objects that we create as we go. So this is definitely not what we want, but we are able to show the users as such. So next thing we want to do is add a database to this. And the database that we'll be using is called Postgres SQL. So if we navigate over to postgresql.org/download, this is going to give us the downloads for the platform that we're working in. Now, when we make this install, we're going to get a server and a client software. So we're only going to be using the client software because the server that we're going to be using is going to be hosted on render.com. So just to check our installation, if we navigate over to a terminal and we type in psql-help, if we see this feedback, then we know that we have the client installed. And basically what we want to do is create a server that's hosted on render.com, and I want to use our client in order to interface with that server. So we're going to jump over to render dashboard and we're going to go new and Postgres SQL. Now it's going to ask you a bunch of information. So first we have to name this database. So I'm just going to name it database. And our database name, I'm going to leave it for it to be randomly generated just because it really won't matter what the name is once we connect to it. I'm going to pick a region that's close to me and Postgres version 15. By the time you watch this video, there might be version 16 or 17. I'm sure they will work exactly in the same way. We should also check that we have a free tier that gives us 256 megs of RAM and 1 gig of storage, which is more than enough for what we'll be needing it for. So I'm going to create this database, and as with every service on render.com, it will take a little bit of time to start up, but once it's ready, it will say available and we'll be able to start using it. For me, that took about 2 minutes to initialize. So once the status says available, maybe give it about a minute more just to run any background processes in case something is still running in the background. But now we can scroll down to connections, and in the connections tab, we'll be able to see the different parameters that we're going to need in order to connect to this database. So right now we have a server instance that is running on render, and we want to use our client software to be able to connect to that instance. So in order to do that, we're going to jump over and we're going to invoke PSQL, and notice that the way that we connect is through these options. We need a host, we need a username, and then we also need a database. So I'm going to start with the host. -H is going to indicate the host that we're connecting to, and the host, if we come over here to external database, so we're going to connect externally using a URL. I'm going to scroll over a little bit here. And after the @ symbol, there is a DPG dash and then something. I want us to copy everything all the way up to the .com, and that is going to be our host. The next thing we're going to need is a username, and the username is given right here. So this, in our case, it's database_NCU9 user. So I'm going to copy that. And then finally, we're going to need to connect to a particular database. And the name that we're given for this database is, again, database_NCU9. So this is going to give us all the information that we're going to need in order to connect to that server. Now, when we connect, it's going to ask for a user password, and the user password is given in this parameter. So we can copy this to the clipboard and we can just paste it here. Even though you don't see it in the terminal, I have pasted it, and you can see that we've connected to the database. Now, in a typical database application, there are 4 things that we can do, and it's represented by the acronym CRUD, C-R-U-D. C stands for create, R stands for read, U stands for update, and D stands for delete. So these are all operations that we can do on our data. So I want to go through each one of these in Postgres. The first thing we want to do is do a \DT. Imagine that all of the data in the database are kind of like Excel spreadsheets. So they're kind of like tables. So right now we don't have any tables, which by the way are also called relations. Tables or relations is where we keep our data, much like Excel spreadsheets. Right now, let's create a table. The syntax for creating a table is we do create table. Now the SQL language is not case sensitive. So that means I can use uppercase or lowercase to give commands to SQL. So what you're seeing here is if I use an uppercase, this indicates keywords in SQL, but it could also work as lowercase. So I'm first going to create a table called products. For products, I'm going to give the column name. So I'm going to have a PID, which is of type serial. I'm also going to give it a name, which is of type varchar 255, which is really just a string. I'm going to also give it a price. Maybe this is a unit price, which has the data type money. And I'm going to have quantity, which is of data type integer. So this is going to create for me a table called products. And just while we're here, let's create another table called users. I'm going to do a users table, which is going to have a UID. This is a user's ID, which is also serial. I'm going to have a name for my user, which is again a string. So a varchar 255. And I'm going to have, let's say, a size, which is an integer, and also maybe a password, which is once again a varchar 255. This is going to create for me two tables. And now if we take a look at DT, it will tell us that we have two tables defined and ready to use. Now, in addition to this, there is also a command which is \D, which is describe, and we can give it products. Products is going to tell me that products is described as a column, which is PID, a name, a price, and a quantity. And it also gives us the data type that it associates with. Now, this is a pretty important tool, especially if we forget what our schema looks like. But the other thing that I want you to see is that serial is actually represented internally as an integer, which has a next val function associated with it. So in short, what serial data types allow us to do is auto increment as we go. So when I enter a product, it's automatically going to give it a unique identifier in our table. So you're going to see that in one moment. Let's insert some products. So I'm going to do insert into, and once again, the capital letters here are representing keywords in SQL. I'm going to go to my products table. And this time I'm going to have a name, a price, and a quantity. And I'm going to insert the values. So notice that this first part are the variables, and the values are going to be monitor. Let's say I have a bunch of monitors, and monitors are 395.50. And let's say I have 12 monitors. So I'm going to insert that into my database. So this is, imagine like this is an object that I'm creating and inserting into the database. And now I'm going to, let's do a couple more. Let's say the next thing I want to enter are mice. So I have a bunch of mice, and each mouse is, let's say, 1565, and I have 20 of them. I'm going to also do another insert. Let's say this is a keyboard, and let's say the keyboards are 1050, and I only have 9 keyboards. So I'm doing a bunch of inserts here, and so these represent objects that I'm going to be working with later on. So one way that we can see what our table contains is using a select command. So remember, the second part of our CRUD is reading. So select, I can do star, and this is generally where we would list the columns that we're interested in. Star just means give me all the columns from our products table. And now you can see that we have all of the products that we entered. Now the next thing we want to do is have other ways to select. So we'll do a select, and let's say I'm only interested in the PID and the name and the price. And I don't really care about the quantity. So I can say from our products table, and then I can do where. So I can add a where clause, and the where clause is a condition that I want to use in order to grab specific data from my rows. So for example, I might say quantity is greater than 10. So I only want those rows that have the quantity greater than 10, and I only want to display PID, name, and price. So not everything, not every column. So you can see now it only specifies those 3 columns, and it only gives me those quantities that are greater than 10. So we can play around with these, and we can also add an and in here if we want. So we can say and name equals monitor. So this is generally how we do a read on the database. Next, let's talk about updating the database. So there is a keyword called update. So I'm going to do update products. So this is, again, the table that we want to update. And we have a keyword called set. Now we can just list a bunch of things we want to set. So here, let's say I want to set the price of my keyboards to something else. So I want to up my price of keyboards to $13.50. And I also want to rename the name of my keyboard to gaming keyboard. So I'm going to change the name as well as the price where the name is equal to keyboard. So we can say this, and what this is going to do is first get all the rows that have this condition, and then it's going to overwrite these properties. So if we do this, and now we take a look at our select star from products, we'll see that keyboard has been updated to gaming keyboard and the price has been updated accordingly as well. All of these things we'll be able to do programmably. Now, it's not important that we fully understand the SQL language, even though we're relying on Java to translate a lot of the commands that we have in our application into SQL commands. It makes a lot of sense to know what they mean. So the last thing we want to talk about is the delete command. So delete is the keyword delete. And then again, we have to supply the table. So delete from products. And we can actually give the command here, but if we do this, this is going to delete every single product. So be very careful about using the delete command. We typically will have a where clause associated with it. So where the PID is equal to 1. So here I want to delete the monitor. Okay, so if we delete, and now if we take a look again, we'll see that the PID 1 is gone. Right, so this where we can also delete multiple items at once as long as this condition is met. Okay, so we can do where PID is equal to 1 or PID is equal to 2. That would have deleted the first 2 items in our table. Now, the final thing we want to talk about is to drop tables. So we can do drop table products, and this is going to drop our products table. And similarly, we can do drop table users, and this is going to drop our tables users. And now, if we take a look at DT, now we have no relations again. This is just how we interact with the database itself. But right now, we don't want to have to interact with the database. So I'm going to quit this, and this is going to disconnect me from the server that is over here. So now I want to connect my application to the external database server. So how we're going to do that is first jump into pom.xml. Now this one is very important because we have to have all of the dependencies set up properly. So the first thing we're going to do is look for the Postgres SQL driver. And we'll see that, well, we'll say proceed, and you'll see that SQL dependency will be installed here. The next thing we're going to do is look for a dependency called Spring Boot Starter JBC. So I want to get rid of this dependency. So I'm just going to comment it out, and I'm going to make sure that data JPA is still enabled. So the 2 dependencies that I will need is the dependency for data JPA as well as Postgres SQL dependency. So we're going to save this, and we're going to allow it to synchronize. And we're going to make sure that our application is still running properly. And the next thing we want to do is now we want to associate a table with the data that we have in our application. So for example, here we have our users.java data. I want to represent this as a table. So I'm going to jump over to our users class, and I'm going to give it some annotations to tell it that it is actually a table. So the first annotation I'm going to add is called entity, and entity is going to come from Jakarta persistence entity. And in fact, there's going to be a lot of annotations I'm going to add from here. So I'm just going to do star. The next annotation I'm going to add is tell it that it is a table, and the table name that I want to associate with it is called users. In effect, every user that I create here is going to correspond to a users table in my database where the table name is called users. All right, so you're going to see that in 1 second. Now, the next thing we're going to need is, remember in our SQL, we had the serial UID, which was used for identifying uniquely every single user. So here I'm going to do the same thing, except I'm going to do it with an annotation. So I'm going to annotate as an ID. So again, you'll notice it comes from the same place. I'm going to also call it a generated value, and it's going to have a strategy equal to generation type dot identity. And basically what these 2 lines do is they create a serial data type for the variable that I'm about to create, which is called UID. So this integer UID is now going to have the serial type based on those 3 things. So we're just basically teaching the users class how to create this table. So this table is going to have 4 attributes, and one of them is a UID that is going to auto increment. Now, just while we're here, I'm going to set the getters and setters. And And I'm going to save this and make sure that it does install properly. And then we're going to, now before we move forward, I actually want to do a very quick refactor here. So I actually want to rename users to user. Now this is just a naming convention and it's not very important, but under models, typically every model that we create is going to have a singular form instead of a plural form. This is just a naming convention. So I will have to head over to users controller just to save it and just make sure that everything is running properly. So there are still no errors. And now I'm going to create another file called userrepository.java. In the userrepository.java is going to be an interface. And what an interface in Java is, it's a set of operations or a set of methods that needs to be implemented to fall under that category. So interfaces can extend other interfaces. So there is an interface called JPA repository. So JPA repository is going to come from this import here, and JPA repository will need me to attach it to a class that is already defined as a table. So I'm going to attach it to the user class. So I'm going to attach it to the user class. And then the second parameter, I will need to give it as what is the ID type. So it's an ID of integer. So here you see that the ID is an integer. So I need to put that as the integer. And basically what this allows me to do is now I can interface with the table and I can find, I can add and I can delete certain items based on that user class. So I can, for example, enter new users and automatically this repository is going to translate that code into SQL to send it over to my database. So in effect, it relieves me of having to learn SQL. Now, in addition to this, we can also add our own methods for our user repository. So as an example, maybe at times I would find it helpful to find a list. So maybe I'm going to do list, and maybe I want to be able to find user by the size. And I'm going to pass in an int size. Now you could probably guess what this is supposed to do. This thing, and let me just add the import here. This thing is going to give me a list of users, and this function is going to be invoked find by size, and this is a standard. So find by and then whatever attribute that we have in a camel case representation. So we're going to have to pass in the size. So notice that here size is one of the attributes. So now I can find users based on a size that I pass in. Now similarly, I can have another list of, again, users that I can grab, and again I can do find by, and this time maybe I want to find them by name and password. Okay, again, notice the camel case, and this time I'm going to send in a string with a name and also a string password. And once again, I want you to notice that the variables that I'm sending in corresponds to the variables that are here. So automatically, this is going to implement that function, and I'm not writing any SQL. So I can now invoke these functions just by calling them. So I'm going to save this and make sure that everything is running correctly. And so I've set up a user, which I've identified as a table. I've set up a repository, which is kind of an intermediary between our code and SQL so that we don't have to write any SQL. And the third thing that we're going to have to do is now we need to connect to the actual database. So if you take a look at the resources folder, under the resources folder, there should be a application.properties file. And right now we have nothing in that application.properties file, but what we want to do is set up all of the metadata that we're going to need in order to connect to our external database. So remember all of the attributes of connecting to the database that we had before. We're going to set all of that up. So the first thing we're going to do is we're going to set up the Tomcat access log enabled. We're going to say true. This is not necessary, but this will help in debugging purposes. So the next thing we'll do is set up some rules for the database. And we're going to set up two rules, one for the Hibernate DDL auto, and this is going to update. So what this means is that it's going to update the table as it sees fit. So for example, let's say I have an iteration where I decide, oh, I need to add another attribute called age in here. And so what this is going to do is automatically go to our table and update that column. Even if we delete columns or anything like that, when we start up our application, it'll automatically check for schema changes and it'll update accordingly. The second line shows the SQL that is executed on the console. So the next thing we're going to need is a Spring data source URL through JDBC : and then Postgres SQL. So make sure we spell this correctly. So this is the scheme that we'll be using. This is the protocol that we'll be using. And the host is going to be, if we come down here to the external database again, if we scroll across, we'll see that after the @ symbol, I'm going to copy everything. So copy everything after the @ symbol, and we'll get something like this. So this is going to be our URL. This is the URL that we're connecting. So we're from our local machine, I'm going to connect externally to this database. All right, the next thing we need is we need a username and a password. So I'll start with the username. The username is whatever we copy from here. So our username here is database_ncu9_user. And then finally, I'm going to take the password, which is this right here. So I'm just going to copy this and paste it on here. And in general, this is not a good idea because you can imagine this file is public. And when we push this to GitHub, if we have a public repository, people can take our password and they can connect to our database and do anything they want to it. So usually how we do this is we would hide this in an environment variable. So for the more advanced users, that's what you should be doing. But for now, we just want to be able to connect to the database. After we set this up, hopefully we won't see any errors. So the server is currently running and it actually restarted itself based on these parameters. So that means we've connected to the database and we've set the user as a table. And then now we have a repository as an intermediator for our data. So if you ran into any problems at that stage, I would highly recommend that you go back and take a look at the POM XML. So as I'm saying that, I see that we have a problem here. So let's scroll up. It's probably good that we ran into something like this. So if we scroll up, it'll usually tell us what the error is and how to fix it. So here it seems like it's a Spring session problem. So if we go to POM XML, which we're already here, if we take a look at where the sessions are, so we have a session JDBC, and I think there's some sort of conflict there. So let's change it to session core. And you could also just remove this dependency altogether. So hopefully if we did everything correctly, I'm just going to stop this server and restart it because generally that helps a lot when we're debugging dependencies. So I'll restart the server and hopefully it won't give us any problems anymore. Now, what we do want to find out is what happened to our database. So right now, as we start up this application, a database call would have been from our application over to the external server. So if we take a look at this external server, and another way that we can connect to this server is we can just copy this PSQL command straight into our terminal. So I'm just going to copy this and head over to my terminal, and I'm just going to paste this in there. So I know before there was another method that we can connect to the database, but this is actually shorter. So here we can now take a look at our data tables. And we'll find that we have a data table that is users. And that makes sense because our application, when it started up, it would have came to the database and it would have created this users table for us because we have a definition that's in user.java. And if we take a look even further, if we describe what users is, it'll tell us that users is made up of UID, name, password, size, and you'll see that UID is a serial. And that is also exactly what we wanted. So this is great. So the next thing we want to do is let's interface with this server even further, and I want to add some details to the user's controller. So here, remember before, I got all users by creating some users and then I added it to a list, but this was done manually. So what I instead want to do is I want to get this from the database. And how we do that is we need to have a few more annotations here. So I'll start off by doing an AutoWire private user repository, one that we just created. And I'm just going to call this user repo. So this user repo is what I'm going to be using in order to save data and also to find data from the database. All right, now in here, instead of making an array list by ourselves, we're going to do user repo. And then notice that there is a find all command. Now this find all command is equivalent to the select star from users that we talked about earlier. And I think this is going to do it. So I can get rid of this to do. And now we get the users from the database. Now notice this user repo connects to the database for us, grabs all the users, and then puts it in the US variable. And then it should display all the users. So let's save this and make sure that everything is still running correctly, that we haven't made any mistakes. And now I'm going to head over to my application. And right now, if we go to user/views, you'll see that there's actually no users currently, but we did send the command select all of these things from users. And that makes a lot of sense to me. So right now we're good. We have the find all. We can interface with our database and we can grab all the users. So the next thing we want to do is let's add a functionality to be able to add a user to this. So I'm just going to go into the static files And let's create a new file called add.html. This add.html, I'm going to create HTML5 template code, and I'm just going to add some bootstrap to it. So let's call this add user, and we're going to bootstrap it. Then I'm going to create a form for adding a user. So I'm just to save us a little bit of time, I'm just going to copy and paste some code that I already have. So here we have the main div, which is a container, fluid, and I'm going to have a row and then column, which is MD4. So it's going to be slightly smaller. I'm going to have a H1 that says new user, and then my action is going to go to users/add. Okay, so next we have two div boxes for our name and our password, and then another div box for the number, which is going to represent our size. Now, I want you to take note that this name attribute is going to be the variable that it corresponds to once all of this data comes to our server. So once again, we're going to send it to an endpoint called users/add, and I'm going to use a post method in order to send it to our server. Now here, this submit button, when I click send, is going to send all of this data over. So just for a second, let's see if this is working. So I'm just going to go to add.html. You can take a look. We have the username. Actually, I don't want the placeholder to be username. I want it to be called name. So I'm going to have name, password, and size. And all of this is going to be sent over to my server. And in the server, I want to be able to write some logic to receive all of this data. So once we have all of this data and I click send, it's going to send it to a backend called users/add. So let's jump over to our users controller and let's add that endpoint. So here I'm going to use, instead of a get mapping, I'm going to define a post mapping, and our post mapping is going to have an endpoint called users/add. And once again, we're going to have a variable associated with it that returns a string. And then this time I'm going to call this function add user. Add user is going to take in a couple of parameters. So we're going to have a request param, and request param is going to be in form of a map, which is a string followed by a string. All right, so this map is actually defining for me that we have a string of a key and also a string for the value that's coming in. I'm going to call this new user. So new user, and then I'm going to have a second parameter, which is going to be an HTTP servlet response. And this servlet response is going to help me with the response that I'm going to give in my server. So let's bring in this map from Java util, and then we're going to need a return statement. All right, so let me start with the return statement. So we're going to return a file called added user.html. So we're going to return added user, and in a second, I'm going to create that in my templates. Actually, to keep things a little bit more organized, I'm going to do users/added user, just so that we have it inside of that file. So next, let's write the logic for what we want to do when we actually add a new user, because this web page is just going to show some feedback. So as always, we're going to do an sout, and here we're just going to print out what we're doing at this endpoint. We're going to say add user. All right, so this is what we're going to be doing in this endpoint. Just like before, we wrote getting all users. This is just good feedback to see which endpoint has been activated. The next thing we'll do is we'll do a string, and I'm going to have a string for the new name, and basically for all the parameters that are coming in. So new name, I'm going to go from the new user. Now remember, new user is a map. So I'm going to get the value that the key it corresponds to is called name. So basically what's happening here is I'm grabbing the new name from this thing right here, this text box right here. All right, so I'm going to grab that, and I'm also going to do the same thing with the password. So the password, again, is just a string. So we're going to do new password, new user.get, and this time I'm going to be grabbing the name password, so the key password. And then the final thing I'm going to get is the size. Now the size is a number, but it will be coming in as a string. Okay, so any communication that happens on the web is always via a string. So if I want to make an integer called new size, I'm going to take new user and then .get, and then this time I'm going to get the size. But the thing is that this is going to represent a string. So I'm going to change that into an integer by doing integer.parseInt, and that should give me the three things. So I grab all of the data that's from the form, and those are the form data. And now I want to create a new user. The intent of this new user is to put it into the users table in the database. So we'll do user repo.save, right? And this is what's going to save a new user into the database that I have in the server. So I'm going to do new and then user. Now notice that new user requires a name, a password, and a size. All right, so that should create for me a new person or a new user, which I'm going to use as an object to save it into the user repo. And so the user repo, once again, is going to do the insert command into our database. And again, this allows us not to write any SQL at all. So now the final thing I want to do is give a little bit of feedback in terms of the response. So response object dot, and I'm going to set status. And what a status is that we have a integer that represents what the status of our server is. Now, 201 status means I just created a new object. So finally, I'm going to return added user. So in here, I'm going to create a new file called added user.html. This added user.html, I'm going to have some template code, and I'm just going to say success. Okay, so once we see the success page, we should be happy that this code has been added or this new object has been added. All right, so I'm going to save this, make sure I haven't made any mistakes. I'm going to navigate over to add.html, and let's add a new person in there. I'll have a password, and then we'll just add a size of 25. And now I'm going to send, and hopefully this will work. Nope. And I think the mistake that I made here was users. So it was in the users folder, not user folder. So let's try that again. And I'm going to go back and send this in again. I'm going to use a different username. So Steve, and then I have a password 1234. And let's say the size is 35. So we'll send. Now it says success. And now if we take a look at our database. So this was our database. And if we do a select star from users, we should see that we've added both. Now, the first time it did actually add successfully. It's just that it was not redirected to the page properly. So both of these people have been added successfully. And if we just want to verify that, we can go to users view, and we can see now all the users. So now the good thing about this is that we're not adding Bobby and Steve every single time through. This is now stored in our database. So every time we restart our application, this data is always going to be here. So now at this point, let's say we're very happy with our application. Everything is done. We're ready to push it into our production setting. So that is found on render.com. But the problem is currently we are running this application locally, and we are connecting to the database through an external URL. So the external URL basically is going through the internet and is connecting to render.com's Postgres instance. When we push our application onto render.com, we want to actually use an internal database URL to connect to our database. And this just secures our application a little bit better. So when it comes time to push it, secure our application a little bit more by going over to here and taking a look at our internal database. So again, just copy everything after the @ symbol. And now I'm going to go over to my application properties, and I'm going to replace this with what I just copied. So this is our internal database URL, and this means that when I push this application up to render, we're going to use an internal URL in order to communicate. Now, the good thing about this is that now it doesn't matter who knows what my URL is. It doesn't even really matter if people know my password. They won't be able to access my database without knowing what my URL is. All right, so the last thing we're going to do here is we'll stop our server. And once we're happy with it, we've saved all of these things. And the last thing we're going to do is we're going to push it up to our repository. So we're going to do a git add again, and we're going to do git commit, and we're going to label this added internal database. And now we can do a git push origin main. And now if we take a look at our deployment, you'll notice that it is in deployment, and we can just wait until it deploys. So right now the deploy has succeeded. If we go in and we take a look at our application again, of course, the main page is going to give us still this error page, but let's go into now users/view. Now we can see our users, but you should note that these users are coming from the database. So this data is going to persist even if we do many pushes and even if we do restarts on our application. All right, so that's all I have for this video. Thank you for watching. I'll see you next time.